Alright, so I'm going to go through and show you the reactions that occur when you have an unstable nucleus. And so radioactivity results when you have a nucleus that is unstable. And two forms of radiation that release particles that we looked at include alpha radiation and beta radiation. Now these are really nice and easy. The reactions are really nice and easy to show, and so I'm just going to go through this, and this is also a very nice review for the symbols for certain isotopes. And so first of all, I'm going to start out. I've got uranium, and so you need to open up your periodic table, search for 238, search for uranium, and you'll find it. The symbol for uranium is U. The mass number I tell you, just right here, is 238. And then you need to find the atomic number. Now for uranium, it's going to be 92. So the reason why this reaction is going to occur is because uranium-238 is not stable, and so it wants to become stable. So what it's going to do is it's going to release an alpha particle, because I told you in the problem it was alpha radiation. Okay. So it's going to release an alpha particle, which is represented in the following way. And then it's going to release one other thing. Now, all you have to do is simple addition. So here the total is 238 for the mass number. So if I lose 4, that means that this is going to have to be 234, because 234 plus 4 is 238. And then the atomic number, 92 here, atomic number here 2. So this one's going to have to be 90. And so all you have to do now is look at 90, search 90 in your periodic table, and you will find that it is Th, thorium, and you're done. Now, the reason why I included this late chapter early on in the year is because what it's showing you is that if I change the number of protons, as demonstrated here, going from 92 to 90, I completely change the atom or the element that I'm dealing with. And so we've talked so far about manipulating the number of electrons. If I change the number of electrons, what happens is that I end up with an ion. Now that ion can either be a cation if it's positively charged or an anion if it's negatively charged. And the other thing that I can do is I can change my number of neutrons. Those can differ. If I have different numbers of neutrons, so for example if I have C14, remember carbon has an atomic number of 6, so this would have 8 neutrons, this would have 7 neutrons, and this would have 6, C12. These are isotopes of each other. The only thing that differs, their electrons, their protons are the same. The only thing that differs are their neutrons. And so the point of this is to demonstrate, well, it is actually possible to remove protons. But first of all, it releases radiation, which is extremely dangerous and high energy. And not only that, but it also completely changes the atom that you're dealing with. So, I'm going to now do beta radiation. Remember, alpha radiation isn't able to affect us as easily, right? It can be stopped by simple clothing. But once it's inside of us, it's much more dangerous than beta radiation. Now, beta radiation is much more permeable. It can get into us a little bit, but not to the same degree as other types of radiation. But it also isn't as dangerous as alpha radiation. All right. So in this one, I've got actinium-228. So you've got to locate that on your periodic table. You can use average atomic masses to kind of locate where it should be. And actinium, which is AC, has a mass number of 228. Because that's what's told to you in the problem. I would have to give that to you. Oops. So I need to put 228 up above. So 228 up above. And then the atomic number of actinium is 89. Okay? And so the reason why this reaction occurs again is because actinium-228 is not stable. And so to become more stable, what it's going to do is it's going to release a beta particle. And this is what a beta particle looks like, just like that. And so what your job now is to do is to find the other thing that's going to form as a result of this. Now, 228 equals 0 plus what? Well, that's still 228. That doesn't change. And then for the atomic number, what plus negative 1 equals 89. So basically, what minus 1 equals 89? Well, that's going to be 90. And so if you look at your periodic table and search atomic number 90, you get, again, thorium. So in both of these cases, you've got uranium in this one, you've got actinium in this one, and the important thing for you to know is that they're not stable. And so the ultimate goal, what we're going to be dealing with in chemistry in general, is the fact that unstable things want to become stable, and so they're going to do whatever they can to become stable. So in this case, they'll release an alpha particle. In this case, they'll release a beta particle in order to become new and more stable atoms, to have more stable nuclei. And so that's all there is to it.